So in this unit, we're going to go over solving. This is a really, really important unit. This is a strong idea in algebra, and so we'll talk about solving and solutions and what solutions really mean. Our first section, we'll talk about solving equations. Next, we'll apply those same ideas to solving inequalities. Lastly, we'll really talk deeply about what solutions mean. All right, so let's go for it. So, if you're solving an equation, let's first talk about what your answers will look like, or what your goal is. Your goal is to isolate x. And when I say isolate x, I mean have x by itself. Your goal is to have an answer that looks something like x equals a number. And maybe there isn't an x, maybe there's a t or an a or whatever the variable is. Your goal is to isolate that variable, so you'd have an answer like a equals 7 or t equals 9. That's how you'll know that you've solved the equation. So I have a bit of a strategy here, and I'm going to kind of add to this. In terms of solving, solving is different than simplifying. It's kind of the opposite of simplifying. So what you're going to do, in simplifying you did PEMDAS. Here we're going to kind of do reverse PEMDAS. So instead of PEMDAS, we're going to kind of do SADMAP. What I mean by that is we'll begin with adding or subtracting, then multiplication and division, and then we'll kind of deal with the other weird stuff. Okay? So our goal is to isolate the variable. Let it be x, let it be y, doesn't matter. We're going to add or subtract first, then usually we'll end up like dividing next, or maybe multiplying. And we want to isolate the variable. So this first line, this first strategy is what we're going to use on this first example. However, on our next example, we're going to have to distribute and then combine like terms before we can kind of enroll in our reverse PEMDAS initiative. Okay? All right, so let's try this first example. Now, our goal is to solve for x. We'll have an answer like x equals. So if we look at this equation, I know it's an equation because there's an equal sign right here. If we look at this equation, I see that here's x. I really want to get x alone. First thing I'm going to do is I'm going to add 1 to both sides. Now I'm kind of thinking of reverse PEMDAS right here. I'm thinking about addition or subtraction first. And notice how there's a -1 here, or subtracting by 1. What we're going to do is we're going to do the opposite, or the inverse of subtraction. The opposite of subtraction is addition. So notice how we're going to add 1 to both sides of the equal sign. You can think of the equal sign as like sort of like a balance beam. You want to keep things on both sides of the equal sign balanced. So if you're going to give a weight of 1 to one side, you better give that weight of 1 to the other side as well. And the reason why you did that, why you kind of did the inverse or the opposite operation, is because -1 plus 1 makes 0. Okay? So that kind of cancels out those numbers. So you'll have 3x on the left-hand side plus 0. And on the right-hand side, I'm kind of going vertically here. 8 plus 1 is going to make 9. So if you want, you can kind of rewrite this. But you don't really need that 0 there anymore. If I add 0 to your bank account, I'm really not going to affect it at all. Okay? So now, what we're going to do, we've done the addition or subtraction region of reverse PEMDAS, otherwise known as SADMAP. Now what we're going to do to isolate x, to get x alone, is I notice that we have 3x here. We really mean that that's 3 times x. So now you have to ask yourself, what is the opposite of timesing or multiplication? The inverse or opposite of that is division. So we'll divide both sides by 3. Notice, since this is an equation, since we're keeping things equal or balanced, whatever we do on one side, we'll do on the other. Now what's cool is 3 divided by 3 is equal to 1. If I had $3 divided by 3 friends, each friend would equally get $1. So that's 1 times x. What is 1 times x? Well, that's just x. What is 9 divided by 3? That's just 3. So now we have solved for x. We arrived at our goal. We have an answer that is just x equals a number. Now what we should do in this problem, and really in every problem before you hit submit on the Accuplacer, is check your answer. So we're going to go back to the original problem, which was written in black. It said 3x minus 1 equals 8. So 3 times our solution, x minus 1 equals 8. And now we're going to substitute. In place of x, if x is equal to 3, when I say x, you say 3. In place of x, we'll put a 3. And then we'll actually see, is the left-hand side, when I simplify that fully, using normal PEMDAS, is that the same thing as 8? And yes, it is, because with PEMDAS, we'll do multiplication first. 3 times 3 is 9, minus 1. Does that make 8? Yes, it does. 8 equals 8. So you know your answer choice is correct. You must always check every answer before you hit submit. I cannot stress that enough. So now, and that problem should have been pretty basic. You should have seen a bunch of problems like that in your life. And now we're going to get to some more complicated problems. So normally, to solve an equation, when your goal is to get an answer like t equals or x equals or a equals, your goal is to do reverse PEMDAS. You're going to do inverse operations to solve for the variable, to solve for x or y or a or b or c or d. However, sometimes you'll have to distribute or combine like terms first. The Accuplacer loves to have you do this first. Okay, so this is, quite important. Okay, so now we have a similar example, this example down here, but it's a little more complicated. We can't just start doing reverse PEMDAS. Instead, we're going to have to distribute first. So we'll have the 3x. We'll distribute the negative 3 to the 2x. Negative 3 times 2x is negative 6x. We'll also distribute the negative 3 to the negative 1. Negative 3 times negative 1 is positive 3. Negative times a negative is a positive is very important. That's going to happen a lot in the Accuplacer, so be really mindful of that. So now we have distributed. Now we better combine like terms. 3x minus 6x, that's negative 3x. And then I'll just rewrite everything else I have. Now, this problem looks a lot like this original problem up here. We have distributed, we've combined like terms, we've neatened things up. Now, we'll do reverse PEMDAS. I'm going to subtract 3 from both sides, because that's the opposite or inverse of adding 3. And I'll rewrite it. I'll have negative 3x. 3 minus 3 is 0, so that's gone. And then I'll have my minus 3 over here. 9 minus 3 is 6. Divide by negative 3, because that's the inverse or opposite of multiplication. And x will equal negative 2. You really need to see those negative numbers. Kind of like if I look at my bank account, I better be mindful of when things are positive and when things are negative, because the Accuplacer might have the wrong answer here of 2 because you missed, let's say, that negative sign. We know a positive divided by a negative is a negative, so be careful. And then take your answer, and you should do this on your own. Plug in everywhere you see an x into the original problem, and simplify the left-hand side. You better get 9. That's how you'll know you're correct. So this next problem is sort of a multi-step problem, because they're giving you x, and they're giving you an equation with x and y. What we'll first do is substitute in place of x a 2, and then we'll solve for y, just like we did on the previous examples. We'll isolate the variable. Okay, so if x is 2, 5x plus 11y equals 44. Instead of 5x, you know that you should use parentheses. In place of x, we're going to substitute in a 2 plus 11y equals 44. So in place of x, we'll substitute in a 2. And then 5 times 2 is 10. Now this problem looks very similar to the problems on the last slide. Now our goal is to solve for y, solve for the missing variable. And we're going to use reverse PEMDAS. So you see how we have a positive 10 here? That's like saying plus 10. The inverse or opposite operation would be subtracting 10. We're going to subtract 10 from both sides. 10 minus 10 is 0. I'll rewrite this up here. I have 11y. Remember, that just made 0. So 11y alone on one side of the equal sign. And 44 minus 10, that's 34 on the other side of the equal sign. Last but not least, we'll divide by 11. The reason why we divided by 11 is because we had 11y. That's the artist formerly known as 11 times y. So the inverse or opposite of multiplication is division. 11 divided by 11 is 1. 1 times y is y. So y equals 34 elevenths. On the Accuplacer, very commonly you'll get answers that are not whole numbers, and that is okay. And so what I'd like to do is I'd like to actually model solving checking this problem from the top with your answer with this ugly fraction. So what we'll do is we'll go back to the original problem, and in place of x, we'll plug in a 2. They told us x was 2. And now in place of y, we'll plug in our 34 elevenths. And we'll see, does that equal, that's a question mark equals, does that equal 44? So, on the left-hand side we have 5 times 2, that is a 2. 5 times 2 plus 11 times 34 elevenths, does that make 44? So now clean up the entire left-hand side, and hopefully you get the right-hand side. Now we're checking. We want to make sure that our answer is correct. 5 times 2 is 10. And then this region right here, Mr. Alberts went over how to deal with fractions. So 11 is the same thing as 11 divided by 1. You could then notice that you have an 11 in the numerator and 11 in the denominator. All this stuff is multiplied together, so 11 over 11 is 1. 11 things divided by 11 people, each person gets one of those things. So that's going to be 1 times 34. So I'll have 10 plus 34. Does that make 44? Yes, it does. So you know you're right. Now, I'm sorry that this isn't the most neat thing in the world. I'm hoping that your notes are a little neater. It's a little awkward writing with this stylus, but be sure that you check every single answer, even if it's an ugly fraction, so that you know that you're right. Okay, now we have another example. This is another one of those distribute and then combine like terms. So that we can solve for, in this case, the variable r. So let's distribute. This 4 is going to be multiplied by r and by negative 3. 4 times r is 4r. 4 times negative 3 is negative 12. And then we'll rewrite everything else. Now you can actually think about it here. We're going to combine like terms. We'll combine like numbers, if you will. Negative 12 plus 6 is negative 6. Be very careful with your negative signs. We have a 4r on this side, and we have a 2r on this side. Now what's interesting is we still have to combine like terms. So this is a very important example, because I have my variable on both sides of the equal sign. So now what I'm going to do, since I have my numbers here, I have r's on both sides, the least amount of work or effort that I could put forth to isolate r is I'm going to somehow try and bring this r over to the other side. That way I'll have r's on one side and numbers on the other. Then and only then can I isolate r on its own side of the equal sign. So now what you have to think about, if you want to move this r over, you can't just pick it up and move it over. Kids want to do that. They want to like copy and paste and move it over. You can't do that. Instead, what you'll think to yourself is, what is the opposite of 4r? What is the inverse of 4r? Well, 4r is positive 4r. So the opposite of plus 4r is minus 4r. So we're going to subtract 4r from both sides. Remember, this is a balance beam. This is an equation. Whatever you do to one side of the equal sign, you have to do to the other. So 4r minus 4r is 0. So then you just have negative 6 on one side of the equal sign, and you have 2r minus 4r on the other. 2r minus 4r is negative 2r. Now I'm going to bring this up here for more room. So negative 6 equals negative 2r. Now what we want to do is we want to isolate r. r is multiplied by negative 2. The inverse or opposite of that is dividing by negative 2. So whatever you do to one side, you better do to the other. Notice the use of care with negative signs. Negative 2 divided by negative 2, well, that's just 1. 1 times r is r. We've effectively isolated r. And on this side right here, negative 6 divided by negative 2, that makes, well, a negative divided by negative is a positive, be careful, that makes 3. On the next slide, I will go through checking our answer to this problem. So here we're going to check our answer from the previous problem. And so we believe that r equals 3. So now what we'll do is we'll rewrite the entire problem. But everywhere there's an r, we'll substitute in a 3. And then further simplifying this, we want to see, does the left-hand side equal the right-hand side? So now we'll simplify the left-hand side, we'll simplify the right-hand side, and we'll see if they're the same. Notice how we're not going to do any of the techniques that we've used with algebra so far. We're not going to add 3 to both sides and things like that. That's when we're solving for x. Here when we're checking, it's like we're evaluating and we want to see if the left-hand side equals the right-hand side. So let's simplify the right-hand side. We know the right-hand side is just 2 times 3. That's 6. Hopefully the left-hand side is equal to 6 as well. So then PEMDAS tells us to focus on parentheses first, because remember, we're not solving here, we're checking, we're evaluating, we're simplifying. 3 minus 3 is 0. And PEMDAS says next to do multiplication. 4 times 0 is 0, plus 6 is 6. So 6 equals 6, therefore your answer is correct because you ended with a true statement. R equals 3 is correct. You need to check every single problem that you do. That way you'll know that you are 100% right. Okay, good. So here's a bit more solving. I'm going to kind of pick up the pace a little bit. Feel free to pause and rewind. Remember, you want to watch this enough where I even recommend that you redo these problems again on your own. So now to begin, we're not going to do reverse PEMDAS yet. We're not going to do addition or subtraction, then multiplication, division just yet, because we need to do the distributive property. So we have 3x. We'll distribute the 3. Don't forget to distribute it to both parts. Notice how I made a negative times a negative turn into a positive right here when I distributed the negative 3 to the negative 1. So make sure you distribute it to both. Watch your signs. I know that they will have the wrong answer where the student makes a sign mistake. So just be mindful of that. Now we can combine like terms, and then we'll isolate x. So 3x minus 6x, that's negative 3x. Be careful with your signs. Okay, so now we've simplified everything. We've distributed, we've combined like terms. So now we'll just isolate x. We have negative 3x equals 6. We want to get 6 alone. The inverse of multiplying by negative 3 is dividing by negative 3, and therefore x equals negative 2. And I recommend that you plug in and check this answer. When you plug in, the left-hand side should equal 9 and the right-hand side should equal 9. That means that you did not make a mistake and you did everything correctly. If when you check you realize you did something wrong, start it over, try again. Try and find your mistake. If you can't find your mistake, start it over, hit the reset button, because that'll really help lead to success. Now this next problem is kind of a doozy. And I believe you've done some work with fractions already. So what I'm going to recommend we do is, I noticed that 2 out of the 3 fractions involved in this equation have a denominator of 5. Why don't we make this third fraction have a denominator of 5? 1 is also known as 5 divided by 5. So now what I've done is I've given us a common denominator everywhere. So what's kind of interesting, we are adding or subtracting fractions, but now we're also solving. What we actually can do, we can really follow the rules that I've put forth. What we can do is, there's actually a couple of things we could do. Hold on. I actually think that it would be better if instead we first added 1. I'm just I'm going to cross this out. I think that this way is actually more confusing. I'm just going to ignore my notes and kind of go off the grid for a moment. I think that we should say, hey, I want to isolate x. Okay, I don't have to, I really do want to follow my rules. I don't have to use the distributive property. I don't have to combine like terms. So let's add 1 to both sides, because -1 plus 1 makes 0. That'll isolate the expression here that involves x, and then we'll have 1 plus 6/5 over here. We're going to go up here with this work so that we can see it. So now we have 2x over 5, or 2x fifths, equaling 1 plus 6.5. Now we can get a common denominator with these fractions. You've already added or subtracted fractions. Now we can think of 1 as 5 over 5. Then we're going to add that to 6 over 5. Notice now how they have the same denominator. So we can combine those like terms. Now we have 11/5 over here. And then if you want, how you could solve this, you could say, hey, this side is divided by 5 and this side is divided by 5. What is the inverse of division? We've done a lot of what is the inverse of multiplication, where you've done division and 6 examples in this so far. But now the inverse of division by 5 is multiplication by 5. Now you have 5 over 5, which is 1, and 5 over 5, which is 1. 1 times 2x is 2x. 1 times 11 is 11. Now we have isolated x. X is 5.5. And again, plug that in, check your answer, make sure you have it correct. Keep in mind, you might be able to use a calculator. There might be an in-browser calculator for this question on the Accuplacer. So feel free to plug in, use the calculator, if it's too complicated or if it just makes you feel, more comfortable with the problem, and check your answer and make sure that it's right. Notice how I haven't modeled checking here. I don't have enough room, but I have modeled it enough for you where you should be able to check these answers and be confident that you're right every single time. So here we're going to basically follow the same rules as solving, but now we're going to be dealing with inequalities. The prefix in means not, equality means equal. We're looking for situations where we see a greater than or a less than or a greater than or equal to or less than or equal to. Those are all situations where you don't just have equals. You have not equals or inequalities. So to be quite honest, you're basically going to follow the same rules as solving equations. There is this one weird little caveat, and I'll show you an example right now. And then we're just going to dive right in, because really I just want you to feel like this is just like everything you've seen before, just with another symbol that you have to be careful about. So again, inequalities look like this, 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 or this. Greater than, less than, greater than or equal to, or less than or equal to. All right, so let's say I had something like this. We'll make it be 23x is less than 46. Okay? Now, if you want to solve for x, you would just pretend this is like an equal sign, just like you're used to. Now, right now, you have multiplication. X is multiplied by negative 23. The inverse is divide by negative 23. Divide by negative 23. 46 divided by negative 23 is negative 2. This whole thing just turns into a 1 times x, which is just x. But the issue is, when you're solving an inequality and you divide by a negative, you'll actually have to flip the direction that your inequality goes. This may or may not come up on your Accuplacer, but it is like a real, nitty-gritty attention to detail type thing. And let's look at this piece right here to understand the meaning of our inequalities. You might say, hey, Mr. Morbido, Mark Morbido, why are you saying that we have to flip the inequality? That sounds really weird. Well, I'm going to kind of show you why. Just remember, this was our original problem. Negative 23x is less than 46. Now, we have our inequality. We've isolated x, and we have a symbol without an equal sign in it. I argue we should switch the inequality, and here is why. If you make a statement like x is greater than negative 2, you're saying any number bigger than -2. So -1.9 or 0 or 100, any of those numbers would make the original statement true. So let's actually check. Let's check a number close to -2 but slightly greater or slightly less negative. Let's let x equal -1. If we plug a -1 in here in place of x, are we less than 46? Well, -23 times -1 makes 23. Is that less than 46? Yes, it is. That checks. You could let x be 5. If you plug that in, you'll have -115. Is that less than 46? Yes, it is. Every single x value greater than -2 makes this statement true. And you can also check the boundary. Notice how we're saying x can't be -2. We have an inequality here. So if we plugged in a -2 here, we'd actually have a 46. We'd have a 46. And if you plugged in, so I'm checking x equals -2. Does that work? Well, when I plug in -2 here, negative times negative makes a positive. Is 46 less than 46? No, it's not. So you can see that x equals -2 is right on the boundary, and it makes a false statement. So everything slightly bigger than -2 will work, and you'll have your inequality say something that is true. So just treat inequalities just like everything you've ever experienced in terms of solving. Just remember, in this fancy case, only when you divide by a negative, you'll actually switch the direction of your inequality, which way it faces. So now we're just going to treat this just like it was an equation, even though it's an inequality. And we're going to distribute, and then combine like terms, and then isolate x. Remember, our goal with this inequality is to say x is greater than something or x is less than something in this situation. Okay, so we'll distribute. Just pretend like there's an equal sign there. We'll have 9x minus 15 is less than 8x. Okay, now this is kind of interesting. This happened on an earlier problem that I kind of starred with you, where you had variables on both sides. They actually love this on the Accuplacer. So now what I recommend you do, see how you have a number on this side? I don't want to have to move that number. If I have x's on both sides, I might as well bring this x over here. And remember, you can't just copy and paste it over. You have to do the inverse operation. So that will make 0. -15. Now we can combine like terms. 8x minus 9x, that's -x. Ooh, look, we're going to divide by a -1 here. And when we divide by a -1, first of all, a negative divided by a negative yields a positive. Second of all, -x divided by -1 makes a positive x. And third of all, you need to flip the way the inequality sign goes, because we divided by a negative. Now that only happens, again, in inequalities. That is a terrible exclamation point. But be very, very careful. And then what you can do, you can check 15. When you plug in 15 here, you're going to get a false statement. If you plug in something slightly bigger than 15, you'll get a true statement. If you plug in 16, you get a true statement. If you plug in 100 or a million or a billion, you will get a true statement when you plug into the original. And we recommend you check every single time. So now here's another one. Again, we'll distribute in the beginning. Make sure that 2 gets distributed to both parts there. Then I guess we'll bring our x's to the right. And then we're going to divide by a negative again. So we're going to flip the way the inequality goes, and we're going to reduce that fraction to -4/3. And then you can check yourself. Think of a number bigger than -4/3. -1. -1 is slightly more positive or greater than -4/3. If you made a number line, you could kind of scope that out. So if you plug in -1, you should have a true statement here. If you plug in 10 or 50, you should have a true statement here. That's how you know that you're right. So we've already been discussing this a little bit, but I really wanted to call to your attention. When you know that you have a correct solution, you'll know that because when you plug it in, when you substitute it in, when you check your answer, you get a mathematically true statement. If you get a false statement, that means that you do not have a solution. And if you were checking, let's say, and you plugged in your x value and you got a false statement, that would mean you did something wrong and you have to go back and fix it. So then we can start to answer these more deep questions like, is 3, -5 a solution to this equation right here? This is an equation because there's an equal sign. Well, this is like an ordered pair. It's a coordinate or a point. They're saying x is 3 and y is -5. All right, let's plug them in. Let's see if we get a mathematically true statement. Okay, I'm just rewriting everything. I'm using parentheses. We talked about this in our evaluating video. And then in place of x, I'll plug in a 3. In place of y, I'll plug in a -5. And I'm going to see, is this equal? This should kind of feel like checking, except now this is like multivariable checking. We have an x and a y. We have 2 variables. So 3 times 3 is 9. 4 times -5 is -20. Does that make -11? Yes, it does. -11 equals -11. Therefore, yes, 3, -5 is a solution. That means that this point lies on this line if we were to graph this. Okay, so we do in fact have a solution because we have a true statement. Let's try the next one. Same game. We have an x and a y coordinate. We're going to substitute into the same equation, or almost the same equation, a little different. In place of x, we'll plug in a -1. In place of y, we'll plug in a 0. And we're going to say, is this equal? 3 times -1, that's -3. 4 times 0 is just 0. 0 plus anything is just the anything. So does -3 equal -2? No, that's not true. Therefore, no. -1, 0, meaning when x is -1 and y is 0, is not a solution. This point does not lie on this line. Why? Because when we check it, we get a false statement. Okay, so it's really important. You know, solutions generate truth when you plug in or substitute them into the original equation. So here, we're kind of delving deeper into what solutions really mean. We have an x and a y, and what we're going to do is we're actually going to substitute them in. And now they have this fancy thing here. They say a system of equations. Fancy word, you know, if you say system of equations, we really just mean multiple equations. So this is a system. This is a system. This is a system. And this is a system. So what we're going to do is we're going to see which one of these systems yields truth. That's how we'll know that we have a solution. Now keep in mind, we're going to have to plug into both. We're going to have to get a true statement and a true statement, and then we'll know that this point is a solution to the system of equations, whichever one it may be. Okay, so let's plug in. All right, so we'll rewrite this first equation here. In place of x, we'll substitute a 2. In place of y, we'll substitute in a -3, and we'll say, does it make -5? That'll be 6 minus 12. It's -6. That does not equal -5. So since -2, 3 is not a solution right here, we know that this answer choice is wrong. Cross it out. Okay, cool. So let's try another one. Let's try this one on the bottom left. Let's plug in x is 2. Y is -3. And let's see if we get a -1. 2 minus 3, that's -1. So that's true, but you can't stop. Don't rejoice yet. Don't circle this answer choice. You have to check the second equation as well. So we'll substitute in place of x and y. Notice the use of parentheses. It's very helpful. In place of x, we'll substitute in a 2, and y, we'll substitute in a -3. That'll be, on the left-hand side, we have a -4. On the right-hand side, we have a next to that, we have a -9. On the right-hand side, we have a -17. That's -13 on the left, -17 on the right. They are not equal. Therefore, this is not the correct answer. 2 -3 is not a solution to this system. Even though it was a solution to one of the equations, it would need to be a solution or yield truth in both of them. So now let's substitute in 2 -3 into this last set of equations or system of equations. Notice how in place of x I substitute a 2, in place of y I substitute a negative 3, and I say, does that make 8? Well, this is 14 minus 9. That's going to be 5, so that's not going to make 8. So I have a false statement. So since I've weeded out these two answers don't work, and this answer doesn't work, that must mean the third answer works. Now, I accidentally made a small mistake here. I meant to copy this down like so. So just go with it. I apologize. It is good to do process of elimination. If this is wrong, and this is wrong, then this must be right. Notice how I made a small error. I apologize. However, you should check. I want you to know that your answer is right, not just that the other answers are wrong. Just to, maybe you made a mistake. So just really to be careful. So now we'll substitute in 2 and negative 3. And we'll see if we get negative 5. That's going to be 2 minus 7. That does make negative 5. So I have a true statement here. Let's try in this second equation. Notice the use of parentheses for substitution. We have a negative 6 minus a 9. Does that make negative 15? You bet. That means that this coordinate, this x and y ordered pair, when I plug it into this system right here, this equation and this equation, I get true statements, check mark on both. That must mean that 2, negative 3 is a solution to this system. Wow, it's really hot out.